Jamie, we have the video? Okay. Here we go. Now, explain what are we seeing and why are we seeing it in this this particular
Okay,
shade?
so we'll just kind of go around it. So if you look at the OPRs operate on the top left corner. NAR is narrow field of view, which is zoomed in. IR at the top middle, it means it's in infrared mode. So instead of seeing color, you're seeing temperature variations. Okay. And these things are extremely sensitive to in like tenths of degrees. They will tell you the difference to color. So it'll go from black to white. So in this case, white is hot. So if you look down in the bottom left corner, it says WHT. That's white. It means white is hot. So the object that you're looking at is hotter than the sky around it. But what you also notice is there's no plumes. Now, if you're looking at an airplane, when you get closer, you'll actually see the exhaust coming out, and there will be a really glowing plume. That's important as we look at the video. And then most of the stuff on here you really don't need to know. What you can look at is the bottom right corner. It says 19,990 and a B. That's the altitude. And if you look up in the little words where it says HDG and then BALT, it's autopilot. So it's on altitude hold. It's just flying for that. So you can go ahead and play the video. And so those two bars next to the white object, that's a passive track. So what he's done is he's commanded the FLIR to track that. So what the system does is it uses, it's actually tracking, it can track pixels, and it's just basically block those hot pixels, those white pixels from the black ones. And then you're going to see now, pause it real quick. So up at the top, see it went to a white screen with the black object. This is a black and white TV mode. And if you look at the top, it says TV. So narrow in TV mode is actually, you can get closer than narrow in IR. It's literally narrow in IR is about medium in TV mode. So you can get closer with the TV mode. So as you look at it now, in this case, you would actually start to see stuff going on. And even in TV mode, because you get exhaust, you know, the black exhaust that comes out, you'll usually be able to see kind of some of that coming out of the back, and you don't see anything. This thing's just sitting there. And if you look at the top where it says 3 right, that's the pod is looking 3 degrees right of the nose of the airplane, right? So he's just flying along. The bottom numbers, don't worry, those are time. So it's 41:56. So go ahead and hit play. And what he's doing is Chad's going through all the different modes because he's like, oh, I got it. And he's going to try and see the best video that he can get. Now, there's rumors that this video is like 10 minutes long. No, what you're looking at is the entire video. Now, notice where it says 99.9. So hit pause real quick. What that means is while he's got the pod, the targeting pod, because that's his primary sensor right now, the radar is still trying to look at this object and trying to range it, and the radar can't get ranging on it. So the object is doing something to say, I'm not giving you back, because it's just a Doppler radar, just like a police radar is a Doppler. It's trying to get a ranging on you, and it can't do it. So when it says 99.9, the radar cannot see this object right now. It's not allowing it to get ranging.
And I think that's super important, Dave, the way he explained it to me. Active jamming compared to passive jamming. This is a technology that is actively jamming this system.
Rather than something like stealth aircraft, which is the shape and the texture of the...
Yeah, it's... Because everyone thinks stealth is invisible. It's not. It's a technology to basically make it harder for radars to see you. You know, and that's the whole thing. You know, if you look at airplanes that are nose on are harder to see than airplanes at the sides. Kind of like think of a barn door. If you're looking at the whole barn door, it's really easy to see. If I turn the barn door sideways where it's really thin, it's going to be a lot harder for you to see it.
Got it.
So that's the easiest, most basic way to look at this. So keep going. You can play again. And you can look, the airplane is still sitting at 20,000 feet. It's doing 250 knots. He's going to go through different modes and try and lock it. And it's just kind of sitting, and all of a sudden, as the video goes on, I think it's a minute and a half long. See, it's going to try and reacquire. It recenters the pod. So it's slowly drifting to the left. The Hornet is still going the same heading. It's just kind of hanging out. And they're just filming this thing. And then when they get close, it's going to zing off the left-hand side. When you see it on a full, because this, you think digital, you'd be able to get a one-for-one copy. Unlike, when you copy your album to a cassette, you lose a little quality. Well, you still do in digital world. And off it goes to the left. And that's pretty fast to leave that field of view. When we have big monitors that we look at these when they come back, so we're looking at the original tapes. So
play the end of that again, please, Jamie. So when it's taking off, how fast, when it just sort of like leaves the field of view and takes off to the left, how fast is that going?
I would say pretty fast. It's an estimate. If we had ranging, you could obviously do the triangle and go, hey, because we know how big the field of view is. But for something to leave the field of view that fast with the pod just staring is pretty fast. I mean, it's like out of here.
Like nothing that we have?
No, because we can't. I don't care what airplane is. So let's just use the F-22 Raptor. That's probably one of the. It's probably the best airplane in the world right now, performance-wise. It can't take off like that, especially if it's a hover. I mean, you're talking something that's just sitting in space in the wind, and then it just all of a sudden accelerates. Airplanes don't work that way.
And it's not leaving any exhaust plume.
No, notice there's none. And when you
Play
go
it
back
again,
to the
Jamie,
IR,
at the end.
Even in the IR, you don't.
yeah, see, there's IR zoomed in, and there's no. You would see a plume if that was an airplane.
It's creepy how it takes off.
Yeah.
With active jamming, it's intelligently controlled. There's no rotors, there's no plumes, there's no exhaust, there's no tail fin, there's no tail number. This thing goes from a standstill, takes off. It's a propulsion system we don't have in our inventory, and no other nation does. That's how it's understood by the government.
Now that's so if the fastest plane on Earth was trying to do that same maneuver, this system would be able to track it?
Yeah, oh yeah, it would stay with it until it got to the limits of the pod, as far as looking to the left. But
Right.
And the radar would see it. I mean, you get close enough, you're gonna, everything becomes visible because you get burned through with radar and how radars actually work. This one is, you tell me, but this was performance beyond. I mean, it's like when we saw it disappear when it flew in front of my nose. I'm talking something, I'm within a half mile of it, looking at it. And it gets in front of me and just disappears. So we'll just go to something that everyone knows is fast. Let's just say SR-71 that's doing Mach 3. The visibility is 50 miles. So even at 35 miles a minute, I'm going to be able to see this thing turn into a little dot as it goes off into the horizon for probably a minute. The thing that we saw disappeared in a second. Just gone. And that's from two different angles. Remember, the other airplane's 8,000 feet above me because we get close to it at about 12,000 feet. So the other airplane's above me looking down, and when it disappeared, I said, "Do you guys see it?" And they said, "No, it's gone." It just literally was poof.